In this problem, we're taking a look at the phase portrait for this system of equations. X prime is equal to y. Y prime is equal to minus 3y minus x cubed. Of course, this is a nonlinear system, and we don't have particular ways to solve it right now anyway. And so we are going to analyze its behavior based on the equilibria, and we're going to let a computer system draw the vector field and calculate some numerical solutions for trajectories. And what I'm trying to do here is complement that with a description of how we're thinking about it. For equilibria, we want points where neither x changes nor y changes. If x does not change, that means that x prime is 0, which, since x prime is y, means that y is 0. And so that represents the x-axis, where y is 0, all along here. When y does not change, y prime is 0, which means that all of this is 0. I've moved the x minus x cubed terms to the other side, and I have x minus x cubed is equal to minus 3y. Now, because y is 0, minus 3y is also equal to 0. And so if I combine those two together, they're actually 3 points. The 3 points, x equal to minus 1, where x minus x cubed is 0, x equal to 0, where x minus x cubed is 0, and x equal to 1, where x minus x cubed is 0. So there are 3 equilibria points where y is 0 and x is one of those 3 values. Now, plotting where x prime is 0, we already did. That's where y is 0. Now, where y prime is 0, just looking at this, y is 1/3 x cubed minus 1/3 x. It's a cubic of some sort. And along this dotted curve, y prime is 0. Now, if you think about it, if you increase y from a place where y prime is 0, if you just move up on the graph, you're going to get a negative derivative for y with respect to time. And so y prime is negative above this cubic, and y prime is positive below this cubic. Similarly for x, x is not changing when y is 0. If y is positive, then x obviously is increasing, meaning the trajectories move to the right. And if y is negative, then x is decreasing, meaning the trajectories move to the left. Okay, let's just look at one trajectory just to get a sense for what we might be looking at. So I've chosen to start at this point here, which is a point on this cubic where y prime is equal to 0. So at this starting point, y prime is 0. All of a positive y, x prime is positive, so the trajectory starts out moving to the right. Now that we've moved to the right, at this place y prime is positive, so the trajectory is going to start moving up, and above the x-axis, x prime remains positive, and that will continue. So this starts out moving to the right horizontally, but then curves, and both x and y continue to increase from that point on. So this arrow here is the positive time trajectory.